Well, awesome. It's good to be here. Martin, thanks for joining us here on our Partner Edge AI session. And as I mentioned before we started rolling, this is really about understanding the diversity of partners that we have in the foundation, from big tech to startups, and it's great to have you here from WeTec to kind of talk a little about what you're up to and what's happening out there for you in the Edge AI space. And so thanks for joining us.
Oh, you're very welcome. It's good to be here.
And you were on our Career Edge
That's
live
right.
stream recently, which is pretty cool. So that was like, we do this thing where, and I think there's another one coming up in May, where we do kind of a live stream for how to build a career in the Edge AI world. And you were representing the kind of how do you get into the startup biz?
Yeah.
Pretty cool. So,
no, it was good. It was, I think that was my first live broadcast doing the Career Edge piece. And it's been a week of first. I had my first panel with ARM yesterday down in London in Mayfair.
Good.
Silicon Catalyst event down there, and so here we are, my second live broadcast.
So it sounds like, from the clues that you're giving, that you're in the UK, somewhere in the UK. Is that accurate?
Yeah, so we're based in Scotland. We're in Glasgow. The office is in Glasgow. So yeah, we've been going for 2 or 3 years. So as I say, we're only a startup, but I think the fact that we're getting a lot of interest from big industry names like ARM and starting to get revenue as well this year proves that we're moving in the right direction, Pete. So yeah, we're a startup with big ambitions.
So give us a background on WeTec. What's the pitch? What's the elevator pitch on WeTec?
So in a nutshell, we do power and control system optimization. And it's taken us a long time to get to the point where we can, just consolidate what we do. But this is what we do. But we do it in a completely unique way. And it's a completely unique way because we're talking about a shift from system optimization being the domain of like cloud, local, and even edge, compute, to one way we're doing system optimization at the microcontroller level. And so we call our underlying technology UltraEdge, as it's really, as we see it, the next evolution of Edge AI. Edge AI is really current and really doing some amazing things. Our technology is slightly in a different shape in terms of we're at the microcontroller within the control loop. So that's where all of our action happens, and then we make use of that data for all applications up the chain, whether that's Edge AI, Edge Cloud, wherever really. So we're really at that kind of like furthest extreme of the network.
And so what are your products or deliverables, or how would you describe those?
Yeah, so really we're very much a microcontroller level technology. So that's from an IP perspective, that's creating our own microcontroller, our own companion IC. But really the target applications for ourselves so far has been motor drive applications, power inverter applications. So very much focused on industrial automation, automotive. From a power inverter perspective, getting into data centers and grid utilities kind of space. So, you can imagine that even with the amount of investment and development that there's been in, Edge AI, but just really in terms of industrial automation, there's still inherent inefficiencies in power electronics because technology's not really been there to solve all the problems. So we've got these inherent inefficiencies that we just assume are inevitable. And UltraEdge is here to tell everybody that it's not inevitable, because if we can do clever things like not only understanding the data and the operational data that exists within the control loops of microcontrollers, what if we could change the output of those control loops and do some really clever things, such as using AI at a ultra far reaches of the network to take an input and change the output of the control loop in real time, and then what can we do with that? So it's all about getting rid of error signals that we don't need,
Right.
really getting really smart on energy efficiency, on productivity, and also not putting stress on motors. And that's really kind of what we're about. It's like the typical three things, saving energy, increasing productivity, and minimizing downtime.
Right.
And really that's kind of a focus for Edge AI applications, but we're really at the microcontroller control loop level. So just taking
Yeah.
it to the next stage, really.
So are you fabbing, basically you're designing chips to be fabbed and you're also licensing IP, or do you do both, or what's your?
Yeah, I mean, we're a very, very small team, so the motivation to doing any kind of fab work ourselves is pretty low. But we're not writing off that, in the future, and we've got some pretty good partnerships now in place that would be good partners if we did go down that approach. But really, what we're about in the short term is, number one, validating the technology. So we have a number of pilot projects which we're completing at the moment, and we're looking for more. And then it's really about how does the customer want to use our technology. If that's very much an IP play, and deploying our algorithm, our innovation, and our models in existing chips, then absolutely fine. If they want to kind of keep the status quo and have that level of resiliency, then we can apply our technology to supplementary chips and eventually our own chips. So whether that's complete IP outsource of the microcontroller to somebody else, or we start, as you say, fabricating our own microcontrollers sometime in the future, that's something that we'll definitely look at.
Yeah. So do you have kind of your own ML models to kind of optimize power and things like that? Is that kind of how it works?
Yeah, we take inputs from the microcontroller control loop, things like torque and speed and current, etc. And we apply various ML models created with TensorFlow Lite and various other different applications to really work on those models. And we talk about this idea of our ability to detect and respond to error signals in less than 1/10 of a millisecond, which in our opinion is real time. We talk a lot about kind of edge being real time, but we're still kind of observing what's going on. When we're in the control loop, there's no more real time than that. So if we can do this and we can start to respond to these error signals in less than 1/10 of a millisecond, this is really playing in real time. And what we're able to do is be able to apply these models in a really, really lightweight way to be able to still achieve that detect and respond timescales as in 1/10 of a millisecond, plus applying our model and applying our algorithm using systems or processors like TensorFlow Lite in a really compact and light touch way.
Cool. How did you find Edge AI Foundation, or did you guys get involved? Like how did that come about?
Well, I guess we found TinyML first, as in, we've been looking, we've been closely monitoring, what's going on with TinyML for a number of years now. I guess when we started off, we were looking at TinyML as being a really good collection of organizations that are doing really exciting things that we wanted to be involved in. As we've been growing the products over the last sort of 2 years, I think we've reached a level of maturity that it was the right time for us to sort of reach out and make contact. And we were involved in a webinar. I think it was not Christmas gone, but the Christmas before, in fact, where we shared a bit of our technology. But again, I kind of look back on those presentations and often go through the old pitch decks from 3 months ago, and I think, what were we talking about? But back a year ago, it's it's a different message to the one that we have now. So I think now's the right time to get really fully involved in Edge AI Foundation. Obviously, we're this side of the pond, so it's not possible for us to attend, everything that you guys are doing. But things like the Milan event coming up is perfect
Yeah.
for us, and it
Good.
feels like the right time to get involved.
Yeah, I mean, one of the cool things I like about the foundation is we're a very worldwide community. Like we're building community in Taiwan and Asia, Europe, especially a very hot area,
Yeah,
especially with the Milan event coming up, and we just had the one in Austin. Then we're actually going to be planning on in 2026 getting into India. Actually, we'll be in India in December of this year.
yeah, yeah,
It's kind of a huge community out there as well. So yeah, it's pretty cool to see the diversity of folks. Like I always talk about the stack, from metal to cloud. When you want to do edge AI, there's lots of
yeah,
it's a team sport, right? And so, you guys are in there in the slice there, pretty close to the metal,
yeah,
doing your thing, which then and there's all this apps and models and devices and things on top of that, all the way to the
yeah.
cloud. So it's pretty cool that you guys are involved like that. How long have you
Yeah.
been involved with WeTech?
Yeah, so the WeTech's been in existence really for kind of 2 to 3 years. Before that,
Mm.
the previous incarnation was called 5G3i, which was a different technology, different model. It was more
Hmm.
connectivity solutions. But yeah, my background really is I was at Honeywell for quite some time, 13 years,
Mm.
with Big Red H, and left Honeywell to do something a little bit more closer to home. So
Sure.
looking for some kind of like startup position here in Scotland, because I always had kind of European, roles, doing a lot of travel,
Mm.
and there didn't seem to be so much.
Mm.
So
Mm.
I ended up working for Dialog Semiconductor for a while,
Mhm.
which was good, but that was during lockdown. And then I got an opportunity to work for a startup accelerator here in Glasgow called Stack,
Mm.
which
Mm.
is the Smart Things Accelerator Centre. And one of the first companies through the door was 5G3i. So
Mm.
my now co-founder, Tanner, is ex-Dialog Semiconductor himself, has had startups himself, and really the technology really resonated with me. So long
Right.
story short, having supported him in a mentorship role for quite some time, I took the leap to really take a step into founder territory myself,
Yeah.
and
Exciting.
what a big step it was.
Yeah.
You know,
No, that's cool. But there's, as I understand Scotland, I mean, there's quite a bit of tech happening in Scotland. There's a lot of space tech. There's a lot of
yeah,
ocean tech, robotic tech. You
yeah,
mentioned connectivity. I mean, it's a pretty hot spot these days for a lot of startups, right?
yeah. I mean, even going back, I mean, everyone talks about this rich technology that Scotland has developed.
Mm.
The TV, the
TV.
telephone, and, all this kind of crazy stuff. The Watt steam engine and all this kind of great stuff. So there's such a rich heritage in Scotland, in Scotland in general, in innovation. And then you throw into the mix the universities that we have here, which are
Yeah.
extraordinary.
Yeah.
Edinburgh, Glasgow,
Mm.
St Andrews. They all get the kind of the spotlight. But here in Glasgow, we have Strathclyde University that are doing great things as well. And so around that, you have this great startup or technology kind of ecosystem,
Yeah.
which, unless you kind of stop and have a look around, you don't necessarily see. I was always in tech when I was at Honeywell, but I didn't really know what was on my doorstep. So,
Sure.
getting into it and taking a step in and seeing what's here, it's phenomenal.
Right.
As you say, a ton of renewables, robotics. We've got the Robotorium in the Heriot Watt University down the road. So
Mm.
ton of stuff. So it's a really good place to be.
Yeah.
Usual kind of challenges around attracting funding and trying to
Mhm.
get folk from maybe even from London, up to Scotland
Right.
to take a look at what we're doing. But yeah, it's very much a vibrant sort of
Yeah, that's
startup
cool. I
tech
know there's a lot
community.
of hydropower stuff there too going on too. There's
Yeah, yeah,
a lot of
yeah. There
natural
is.
resources from Scotland, like the the geographic positioning of Scotland gives it some unique advantages for like hydropower for data centers
Yeah.
and things like that too, which is pretty cool. So.
Yeah, and as you said, this space industry here is huge. So you go up to the far north of Scotland, there's not a huge amount in terms of built areas around there. So they're building
Mm.
spaceports and things like that
Oh,
up there
shoot
because
some
you've got
rockets
the
off and stuff. Yeah.
yeah, absolutely.
Awesome. Yeah. So what else is happening? Like, you mentioned the industries that you're selling into. So, like automotive is a big one. I mean, what are your
Yeah,
hot verticals these days for your
yeah.
stuff?
So definitely industrial automation. So anywhere where we have kind of non-linear control. So
Mm,
and this is the whole kind of premise behind what we're doing is you know PID control and things like this has been technologies that have been used for 100 years, and I guess it's one of those, if it ain't broke, why fix it? But now we've got good reason to fix it, which is
sure.
that we have advances in AI models, etc., that allow us to do things differently. But so linear controllers worked really well, but
Mhm.
in the modern world that we're in, there's a ton of applications now which are non-linear. And so if you think about things like even in a factory where you have a conveyor with a different load. We were speaking to a tire company this afternoon that is
Mm,
mixing rubber and all this kind of stuff. So it's non-linear loads. We have this ability to use existing equipment. So it's a very light touch, non-disruptive technology which
mm,
just enhances things rather than is a complete rebuild of what's going on. So in industrial automation in factories, that's big. In automotive, it's also big because it's easy to just think about the traction motor in an electric vehicle, for example, and a real good example of a non-linear control system. So every time you put your foot on the accelerator, and depending on the terrain that you're on,
mm,
you have a response. And what we were able to do is extend range in those vehicles because
mm,
we're decreasing energy consumption, but also
right.
not putting the stress of these kind of peak current overshoots within electric motors and
Mm,
traction motors. So
interesting.
that's the kind of obvious ones, but then even in safety systems. So certainly in electric vehicles, and when we're going through to autonomous vehicles where you have motor-driven safety systems like steering and braking. Now,
Mm,
we're not advocating doing any kind of takeover of the control there, but with the technology at the microcontroller level giving 100% coverage of stress conditions,
wow.
this very much plays into ASIL-D, which is the ISO 26262 requirements that you need for all of these steer-by-wire, brake-by-wire type systems, which is going to
Mm,
facilitate autonomous driving. So
mm.
tons of applications. Our challenge is trying to be laser focused at the moment of cracking one or two of these,
Yeah.
and then building on from there.
Well, it makes sense to go after a lot of these what we call brownfield deployments. I was just talking to someone about that. It's like in the real world out there, people have invested capex and a lot of equipment and
Yeah,
process, and they want to add intelligence. They want to add AI into their process to optimize it, to save money,
yeah,
save power, like you said. It all adds up to a lot of cost savings and efficiency, and efficiency is the new currency.
yeah.
So sounds like you
Yeah.
guys are in the right place.
Yeah, hopefully, and they don't want to rip it all up and start again. I mean,
No,
that's the
no.
thing. With ours, you can start with a single motor. You can start with a pilot project, have it work, and then really quite quickly put it into your R&D line, and then quite
Yeah,
quickly try it out on an active working line.
yeah.
It's more about having the ability to be able to get into the systems to be able to deploy it. That's the thing that we find. I guess the challenge, and that's the kind of pilot projects that we're looking to do, is for
Mm,
those innovators really that get into the PCB level, tinkering and being able to experiment, and that's really where we're at.
yeah. No, that sounds fantastic. So, wow, it's cool. So, I feel like I need to make a trip up to Scotland at some point too, because there's so much
You'll
going on up
be you'll be more than welcome, and we'll
there. That'd
definitely
be
show you the
cool.
sites, Pete.
Yeah, I'm not a golfer, but I heard the golfing's pretty good up there too. So.
Well, you can always spend some time in the 19th hole, as we say, which is
Yes, there you go.
Yeah, for after the round.
Cool.
Yeah.
Well, Martin, thanks for the background on WeTec. Appreciate kind of digging in a little bit for our listeners here to learn more about what you're doing. And yeah, just appreciate your engagement in the foundation and what you guys have been contributing. So appreciate that.
No, appreciate it, Pete. Thanks very much for the invite.
All right, sounds good. Thanks.